Hello everyone. So I welcome you all for the engineering metrology lab. So in this video, I am going to explain how to measure the bore diameter by dial bore indicator. So the aim of the experiment is to measure the bore diameter by using the dial bore indicator. So for this we require a dial bore indicator and we require one hollow workpiece. So for which we need to measure the diameter of the bore. So it is a hollow workpiece. So we need to measure the diameter of this bore using the dial bore indicator. So this is a part of the dial bore indicator. So this is a dial indicator. So this is the dial indicator. So we need to know what is the least count of this instrument. So here already written it is 0.01 mm. So let us, if you see here, we have the two dials. One is the short pointer and there is a large pointer. So if the large indicator moves through, right, for one complete revolution. So here if you observe, so we have 0 to 100 divisions. It is 90, here we have 10 divisions, total 100 divisions. So on the circular dial, so we have the 100 divisions. Suppose if the large hand moves through 100 divisions, the small hand will move through one division. If the small hand moves through one division, so that means, so it moves through 1 mm. Suppose if the large hand moves through, let us 10 divisions. So what is the total distance measured is, so for 100 divisions, so for 100 divisions, the small hand shows 1 mm. Okay, let us if it moves through, large hand moves through 10 divisions. Okay, so what is the linear displacement? Linear displacement is equal to 1 mm by 100 into 10. So that is equal to 0.1 mm. Suppose if the large hand moves through 20 divisions, so what is the linear distance mode is equal to 0.2 mm. Similarly here 0.3 mm at 40th division, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and 1 mm. Okay, so therefore the least count of the instrument is equal to, so 1 mm, that is moment of the small hand is 1 division, that is 1 mm, divided by what is the number of divisions required for the large hand, that is 100 divisions. So therefore it is 0.01 mm is the least count. So this dial bore indicator is a combination of dial indicator and also it is a telescopic gauge. So these are called the telescopic pistons. These are called telescopic pistons. So these are available in standard sizes, and this is inserted in the T handle. So this is the T handle. So in the T handle, we will insert the required size of the telescopic piston. So by unscrewing this telescopic piston, and then we can replace with the required standard pistons, telescopic pistons, and then we can tighten to use the dial bore gauge. And here there is a sensing element. There is so here there is a spring inside the part. There is a spring, so which can be some force. If you apply some force on this element, this will compress, and we can easily insert into the workpiece or component, for which we need to measure the diameter of the component. So this dial bore gauge can be used for measuring the diameters of bores of IC engine cylinders, and also we can use for measuring the diameters of the pipes. So here this figure will provide the self-explanatory. So we need to place this portion into the hole. So for which we need to measure the bore diameter. So if we place inside, so what happens? So because there is some variation in the diameter from the standard diameter, so that will show on the dial indicator. So that variation we can note down. So for conducting this experiment, so we need a dial bore gauge, and so we need a table, right? So standard scale reading. So here the standard scale reading is the standard size of the telescopic piston. Okay, and circular scale reading, that is the reading on the dial indicator, and the least count, and what is the total reading. Total reading is equal to standard scale reading plus the least count into circular scale reading. So and then we'll take 4 to 5 readings, and then we will take the average value. So let us see how this dial bore indicator can be used for measuring the bores of the workpieces. So here we are considering a ring gauge. So this is the workpiece. So this is the workpiece we are considering, and this is the dial bore gauge box. So let us see here. So on these places, the telescopic pistons will be there. Okay. So here you see here it is number 1. So number 1 represents 18 mm standard size. Number 2 represents 20 mm standard size. Number 3 represents 22 mm standard size. Number 4, 24 mm standard size. Number 5, it is 26 mm. Number 6, 28 mm. Number 7, 30. Number 8, 32 mm. Similarly, number 9, 34 mm standard size. Okay. So these numbers are printed at the back side of the telescopic piston. Okay. So I will show in the again in the PPT. So let us first we'll see how the dial bore gauge can be used for measuring the internal diameter of the workpiece. So this is the workpiece we are considering. So this is the dial bore gauge. So initially, first we need to check, right? The large hand should show on the 0 division, right? The large hand should be on the 0 division. So otherwise, what we have to do, we have to rotate this bezel. So there is a circular unit, right? So we have to rotate this bezel such that the large hand should show on the zero division. Then we can use this instrument for inspecting the diameter of the bore. So let us place the. Now we need to press. So we need to press with the fingers, right? And then we can insert easily into the bore. Okay. Now we will see what is the reading. So what is the reading we are observing? So from 0, it is moved through 1, 2, 3, 4. There is a 20, right? 24th division. 24th division. Okay. Or 25th division, right? Slightly it is varied. So it is up to 25th division. So standard scale reading is here 24. So we have taken the number 4, right? The standard scale reading is 24. And again we changed the position. And then we have taking the, what is the reading? 1, 2, 3, 4. After 10, 4th division, that is 14th division. So standard scale again it is 24. And circular scale reading is 14th division. So 24 plus 14 into 0.01. That is 24.14 mm is the total reading. Okay. So we'll change the position at a different locations along the length of the depth of the workpiece. So here we are moving the slowly into the another location, and we are taking the reading. So it is 14th division is coinciding. Again you change the position to certain depth, and then you see. So what is the reading? So here it is 20th division is right on the circular scale. So the large hand is showing the 20th division. So what is the total reading? 24 is the standard scale reading plus 20 into 0.01. That is 24.02 mm. Again we will change the position, and then we will take the, so position is changed. So again we will take the reading. So it is 35th division for the large hand. Okay, large hand is showing 35th division. So total reading is equal to 24 plus 35 into 0.01. That is 24.35. So it is very simple instrument, and the procedure is very simple to measure the diameter using the bores. All these values will tabulate, and then we will conclude. So here you see this is the telescopic pistons. So at this side, so the numbers are printed 1, 2, 3 like that. Okay. Now we will note down the readings. The standard scale reading is 24 for all the 5 cases, and circular reading, circular scale reading we observed first for the first position 25, second position 14, third position is 15, fourth position is 20, fifth position is 35, and the least count of this instrument is 0.01 for all the cases. Okay, So the total reading is equal to standard scale reading is 24 plus list count is 0.01 and circular scale reading is 25, 14, 15, 20, 35. So what is the total value? 24.25 and 24.14, 24.15, 24.20, 24.35. So then we will take the average. So the average value is 24.218. So in this way, we can measure the diameters of the bores using the dial bore indicator. So now we note down the average value under the results section. So the average value of the dimensions using the dial bore indicator is 24.218 mm. So what is the conclusion? So from the table, so it is observed that at different locations, the diameter of the workpiece or ring gauge is slightly changing, is slightly varying from the location to the location. This may be due to some irregularities present in the workpiece, so which occurred during the manufacturing process. Coming to the applications, so dial bore gauge is used to measure the inside diameter of the hole or cylinder or pipe with a high degree of accuracy and speed. So this can be used in automotive industries for measuring the diameters of the bores of the IC engine cylinders. So in the manufacturing industries and inspection industries, we use for calibration purpose, we use the dial bore gauges. Mechanics and machinists uses the bore gauges to measure the wear in the cylinder heads and measure holes in an engine block so pistons fit tightly enough that they don't leak the gases they compress. Inspectors and maintenance employees also use bore gauges to check the dimensions inside injection moldings for quality assurance or in extruder barrels to track wear over time for preventive maintenance. So majorly the dial bore indicators can be used. One is for checking the diameter of the IC engine cylinders, that is bore of the IC engine cylinders, or pipes, and also we can use for measuring the wear, okay, and also for checking the dimensions of inside injection moldings for quality assurance or extruder barrels to track wear over time for preventive maintenance. So in these cases, we use the dial bore indicator. So in this way, we can use for measuring the diameters of the bores using the dial bore indicator. Thank you.